Welcome to sitza.com. Different methods of preparation of carboxylic acid. We can prepare the carboxylic acids from different sources, like we can prepare it from alcohols, from alkyl benzenes. We can also get it from alkyl nitriles, or we can also get it, these carboxylic acids from the Grignard reagent. So from different sources we can prepare the carboxylic acids. In this video lecture we will discuss what are the different methods by which you get the carboxylic acids. First is you can prepare carboxylic acids from the primary alcohols and the aldehydes. If you oxidize the alcohols, you can get the carboxylic acids. A primary alcohol here, this has the CH2OH. If you oxidize it with strong oxidizing agents like KMnO4 in alkaline medium, or we can also use here potassium dichromate in the acidic medium. Both are strong oxidizing agents. They convert alcohols into carboxylic acids. So if you take an example here, this one, this is our decanol. There are 8 CH2 groups here, and then the CH3, and then this is the CH2. This is one propanol. This is the primary alcohol here. If you oxidize it, it converts it into the COH. And here we have this chromium trioxide in acidic medium. We can use this one also as an oxidizing agent. So different strong oxidizing agents we can use to convert alcohols into carboxylic acids. So let's take here another example. If you suppose here we have an ethanol, let's say we got a CH3CH2OH. Okay, so here we can oxidize this molecule with any of these two, or even you can use the potassium dichromate K2Cr2O7. So what you will get a carboxylic acid. You get this carbon will be converted into COH, and you have a CH3. Keep it there like this, CH3COH. Basically this is a two-step process. Whenever we use a strong oxidizing agent, alcohols are first oxidized to the aldehydes, right? This primary alcohol will be first oxidized to aldehyde, but aldehyde can further be oxidized then to the carboxylic acid by the same oxidizing agent, right? If you start with the alcohol, you initially get an aldehyde from the primary alcohols, but since aldehydes are further oxidized, they can be oxidized by the same oxidizing agent, so they convert it further into carboxylic acids. That's why if you have an aldehyde, right, if you start the reaction with the aldehyde, aldehydes can also be oxidized to the carboxylic acids using these oxidizing agents here, right? Suppose you got here a CH3 CH2 C double bond OH. If you use this potassium dichromate here in the acidic medium, again the same oxidizing agent or KMnO4, it will convert into carboxylic acid. The aldehydes can be converted into carboxylic acid, so you get a COH here, and the alkyl group that is attached here will be CH3 single bond CH2 single bond COH. So aldehydes can be converted into carboxylic acids using these strong oxidizing agents. We can get carboxylic acids also from the alkyl benzenes. A benzene attached with alkyl. You can oxidize it again with a KMnO4 alkaline solution of KMnO4 and heat it very strongly, and what you will get, a benzoic acid. First you get a salt of the salt of this benzoic acid, because it's the alkaline medium here, so it will form a potassium salt, and then we acidify the reaction mixture, right? We acidify the reaction mixture here, and then what you get a benzoic acid. Same thing here, if you have a very long chain alkyl group also, right? If you have a very long chain alkyl group, it will again convert this carbon into COH, and first you get a salt of that, and then you acidify it and you get a COH. Even if you have, suppose, two alkyl groups, right? Suppose you got here a benzene which is attached with let's say the two methyl groups, CH3 here, and you got here a CH3, two alkyl groups. Again, if we use the KMnO4 solution in the alkaline salt, let's say the potassium hydroxide, and you heat it strongly, it will convert both the alkyl groups, both methyl groups actually, into COH, right? So now you have a benzene ring attached with the two CO potassium salt, right? CO Okay, so the salts and then what you will do, the second step will be, we have to acidify the reaction mixture. We can use the H2SO4. So once we acidify it, what you will get, you get the carboxylic acid, COH, COOH here. Alright, so you can prepare carboxylic acids from the alkyl benzene. So normally you get here aromatic, carboxylic acids from the alkyl benzene. So whatever is the length, whether it is CH3 or it is CH2, CH2, CH3, it will convert it into the carboxylic acid, COH group. We can get carboxylic acids also from the nitriles and amides also. Okay, from nitriles and also from the amides. See, we have a nitrile is a carbon nitrogen triple bond, and if it is attached with the alkyl group, this is an alkyl nitrile, and you can hydrolyze it. You can hydrolyze this alkyl nitrile when you add one water molecule here across this multiple bond. It converts into the amide, so you get this amide. Alright, you get an amide here. So what happens here basically, this one of the double bond break, these two double bonds, the pi bonds break, and overall the addition is, it is the addition of oxygen on the carbon and the two hydrogens on the ammonia, this nitrogen. So when you hydrolyze it, right, you add the water here, so you can say that the oxygen goes to the carbon, two hydrogens, they go to the nitrogen. This is a multi-step process. When you look at the mechanism, I'm not going to discuss the mechanism, how does this addition take place here. So when you do the hydrolysis here, when you add a one water molecule here in the acidic medium, normally it takes place in the acidic medium, hydrolysis. Okay, so what you will get, you get an amide. And amide you can further hydrolyze it. You can add one more water molecule here. Then what will happen? Now this carbon nitrogen bond will completely be lost, and NH2 will be lost as ammonia. So you get minus NH2, right? It is lost as NH2, and the OH group is attached to the carbon. So what you get now, you get a carbons, double bond oxygen, and an OH. So you got a carboxylic acid here, right? So you got a carboxylic acid. See, these are the two hydrolysis steps. So if you look at the alkyl nitrile, you hydrolyze it, you get first an amide. So this is what you call as a partial hydrolysis. The first step is partial hydrolysis. You are adding only the one water molecule. So if you do the partial hydrolysis of the alkyl nitrile, you will get an amide, right? An amide further hydrolysis, right? You get a carboxylic acid, correct? So that means if you start with any alkyl halide, let me take here an example. Suppose you got a CH3, CH2, Cl. Okay, if you reacted with the potassium cyanide, we know here first alkyl halides, what they happen? They can undergo the nucleophilic substitution reaction. The cyanide can replace this chlorine from here, and what you will get, you get the CH3, CH2, and then a cyanide, carbon nitrogen triple bond, right? Now if you hydrolyze it, complete hydrolysis, right? After the complete hydrolysis, this carbon will be converted into COH, and the nitrogen will be lost as NH2, right? This is the complete hydrolysis, when you convert it into carboxylic acid. When you do the hydrolysis, two molecules of water you add. So the first carbon that is attached with the nitrogen here, it will be converted into COH, right? So this is the C double bond OH, and this nitrogen will be lost as ammonia, as NH3 from here. And now the two groups attached to this one is CH3, CH2. You can keep it there, CH2 single bond, CH3. So you got a carboxylic acid, right? This cyanide ion, this is a very important reagent, because we often use it, if you want to increase the length of the carbon chain in the alkyl group, right? Suppose you want to replace this chlorine by the cyanide. Initially you had two carbons only. Now you can look at this final product, it has got three carbons. So you are adding one more carbon, right? One more carbon here. So the carbon length increases by the one atom over here. So that means we can prepare carboxylic acids also from the nitriles, right? From the alkyl nitriles, or even if you have an amide, you can further hydrolyze it and you get a carboxylic acid also, correct? We can also get the carboxylic acids by the reaction of the Grignard's reagent with the carbon dioxide. Carbon dioxide, there's a double bond, carbon oxygen double bond, so you can do the addition reaction on the carbon dioxide, and we know the Grignard reagent is R negative and the Mg positive. When it breaks, it's an alkyl group is a nucleophile here, R negative, magnesium is positive. So the first step here will be that this Grignard's reagent will act across a multiple bond, right? Suppose you got a carbon double bond oxygen, and this it will attack on the carbon, because this carbon is positively charged, right? When there is resonance, okay, this carbon will have a positive charge and the oxygen will have a negative charge due to the resonance in the carbon dioxide. So this is electron deficient, and nucleophile will attack on the carbon, right? This R negative is going to attack on the carbon, and then electron pair will shift to the oxygen, with a negative charge on the oxygen, and this magnesium will form a bond with it. So you have this magnesium halide, it's forming a bond with the oxygen. And then when you do the hydrolysis, you are adding the water again in acidic medium. What happens? This magnesium and the oxygen bond, it breaks, and you add a hydrogen here, and the OH will go to the magnesium. So you get a carboxylic acid, plus what you get? You get the Mg, OH and X, right? Mg, OH and X. This is what you get when you react to the Grignard's reagent with the carbon dioxide. First, this is a complete addition. First step is the addition of the Grignard reagent across a multiple bond in a carbonyl group, and then you do the hydrolysis. Let's take one example here. Suppose you got a C2H5 group, attach it with the Mg, Br, magnesium bromide, and if you react with the carbon dioxide is like this. This is our carbon dioxide, and now what's going to happen in presence of the dry heater? The first step is that this alkyl group will attack on the carbon, and then there's a shift of an electron, right? There's a shift of an electron on the oxygen. The pi electrons will shift, so you get a carbon oxygen, single bond, negative charge, and there's a double bond oxygen, and there's an ethyl group also, C2H5 attached to this one, and you have a MgBr here also, right? So then what you will get after you do the hydrolysis? After we do the hydrolysis, this oxygen reacts with the hydrogen, so it forms an OH, carbon with OH, double bond oxygen, and you got the C2H5 plus what you get? Magnesium, Mg, and then you got the OH and the Br, right? Magnesium attached with the bromine and the hydroxide. So these are the different methods of preparing the carboxylic acids from different sources, right? Hope you got the concept. Thanks for watching the video. Bye for now.